Hey guys, this is Mr. O'Brien. This lecture is strictly for honor students. It's a supplement to Ionic Bonds, and I'm going to show you how to write the formulas and name the formulas of simple ionic compounds. So what does a formula show us? Now, recall that a formula is a combination of atoms that together create this pseudo-noble gas notation. Now remember that only the noble gases have no charges solo, but all the other elements want to be like a noble gas, but have to combine to create this neutral charge state. So let's see how we can identify the correct formula for the ionic compound, because you've already, at this point, drawn electron dot structures to visually see. Now all we're going to do is just write the shortcut. So again, how do we identify the formula for potassium and oxygen, right? So number one, write the cation and then the anion and the charge. So we know that potassium is a +1 charge from group 1, and oxygen is a -2 charge from group 16, meaning it gains 2 electrons and it loses 1. But you know that like this, it's impossible for oxygen to gain 2. You can't have just one potassium in this situation. So what is the ratio of ions that is needed? Because right now you have a overall -1 charge. Well, you figure out that you need 2 potassiums for every 1 oxygen. And so when we identify that ratio, we can write that ratio in a formula using subscripts. Now, subscripts are these bottom numbers below the element, right? The symbol that tells us how many atoms, or excuse me, ions we need for each one. For anything that requires one ion, we don't write any one. We just typically leave it by itself because that's already indicated as one. So try these out. See if you can create the formula, just the formula ratio of the combination of these ions together would make. All right, if you have any questions, hit me up at tutorial and we'll go them together. Now, how do you write the formula, the correct ratio, right, of cations and anions when polyatomic ions are present? Now, remember that polyatomic ions are a group of ions that overall will gain an electron or lose an electron, right? And here's a list that's found on your textbook on page 224. And to give you a heads up, you don't have to memorize these polyatomic ions. I will always give you that on a test or a quiz, but you're going to need to know how to apply them. So let's take a look. So for magnesium and hydroxide, let's find the charges. Now we know that magnesium is on group 2. There's your +2. But hydroxide, there's no such thing on the periodic table as hydroxide. So that leads us to use the polyatomic ion sheet to find where hydroxide's at. And we see that hydroxide is a polyatomic ion with a -1 charge. In this ratio here, 1 to 1 is not appropriate because overall you'll get a +1 charge. Magnesium needs to lose 2, but hydroxide can only gain 1, right? So this ratio needs to be changed to 1 magnesium for every 2 hydroxides. So with that said, how do we identify the formula? Well, we got to use parentheses. Much like math, that parentheses kind of groups variables together. We want to group and say that all of this polyatomic ion, we need 2 of these polyatomic ions to cancel out one of those magnesiums, right? I'll give you another example. So say for magnesium and permanganate, notice that permanganate is MnO4, right? So how do we write this formula? Well, we know that this is -1 charge and magnesium is a +2. So let's see if we can write it at Mg. And we would need 2 of these magnesium permanganates. So we would put a parentheses MnO4 parentheses 2. Now notice I put the parentheses with the 4, right? Because that 4 is included in this polyatomic ion. This is saying that we need 2 sets of all of these guys. So practice that skill with these examples of the monatomic ions and the polyatomic ions. And if you have any questions, hit me up at tutorial. So how do we write the names of these ionic compounds? So 3 easy steps. Name the cation, name the anion, and then if any anion that you call from the periodic table only, the ending has to be changed to IDE. Let's apply this on an example. So here's potassium and here's oxygen. How do we name this? Well, the potassium is K. We find that from the periodic table. And then the O from the periodic table is called oxygen. But notice that in step 3, we need to change the ending to IDE. Where do we change this ending at? The YGEN changes to IDE. Hence, we call it oxide. Okay? Well, how do we name the ones with polyatomic ions? Well, this becomes a little bit easier. All you need to do is just name the ions. It's as simple as that. In this case here for magnesium and hydroxide, we just call it magnesium hydroxide. Now, please note that the IDE was not changed. That's the name of this polyatomic ion. I did not change the name. So those are the differences. If it comes from the periodic table for the ion or anion table, you need to change it to IDE. If not, leave it as is. Okay. Well, how do we name the salt, copper, and oxygen? Now, these are a little bit different because we're using now transition metals, and it's important to remember that transition metals are those that can have multiple charges. We can't tell what the charge of a transition metal is based on the location of the periodic table. They have electrons that hide. So we're going to treat all transition metals from this area the same way as I'm going to show you now. Now, I know there might be some exceptions, but for right now, we're just going to treat it in that way. The only trick to identifying or to writing the names for transition metals is you have to know the Roman numerals. Now, I have a list here of all Roman numerals, but in reality, you only need to know numbers 1 through 5. So how do we identify 1 through 5 in this case? So 1 is the I, right? 2 would be 2 I's. 3 would be 3 I's. And 4 would be an I before the V, which is 5, right? So this V stands for 5, so that the IV would be 4. And then the rest of them are just for your sake if you want to check them out. So let's apply this. All right, so here's copper and here's oxygen. We're going to name it as copper oxide. Okay, name it and name this one. Now remember, if it comes from the periodic table, the anion, we got to change it from oxygen to oxide, right? It used to be oxygen, and now we're changing the YGEN to IDE. Now, the next part is how to identify the charge, because we need to know what kind of copper is involved in this oxygen bond here, or in this bond here with oxygen. So let's find out what the ratios are. So I know that we have 2 coppers, but I don't know what the charge of that copper is. Maybe you can just leave it as X. And I know I only have 1 oxygen, and I know that that charge is -2. So what, this kind of becomes an algebra question. What times 2 will cancel out the -2 on this side? Well, a +1. And so if we know and we identify the charge of 1 ion of copper, we now can write the formula and identify copper as copper 1, the copper ion that only has a +1 charge. And so we use the Roman numerals in this case to bracket the charge of the Roman numeral. And that's how you do it. Take a look at these examples here. These are typical examples you find in vitamins that we derive some minerals from if you take vitamin supplements. And see if you can figure these out, naming and writing the formulas. If you have any questions, hit me up at tutorial. Good luck.